This 2 power minus 3. 2 power minus 3 and the means meter 2C. Means Monica and the mathematics module. Mains mathematics module ఒకటి ఏమో mains maths module ఒకటి మీరు అడిగినవన్నీ ఇస్తున్నారు ఆ తర్వాత నేను మాట్లాడతాను.
Assalamu alaikum to everybody. In the previous class, we came up to amount of work done. काजिम सर प्लीज मैं आज कर लेता हूँ क्योंकि डिस्टर्बेंस होगा बीच में अगर होस्ट बना है तो लेट मी कंप्लीट दिस डिस्कशन ओके ऑलराइट if suppose for example we are having a thermodynamic process where we are starting from initial volume V1 to final volume Vf then pressure is given to you. If the path is given like this, then the total amount of work done should be taken as total area under the graph. That is area 1 plus area 2, right? That logic we have discussed in the previous class. For example, see here, Pi. If suppose, for example, if I am taking to be as Pi as of 5 atmospheres, Pf is equal to 7 atmospheres, and we initial 2 liters for this particular case, F is equal to 10 liters. Now, volume, total volume is to be taken in terms of joules, right? This is your homework. What to do? Very simple. First of all, take total amount of work done is equal to W1 plus W2. What is W1? Area under the graph 1. That is a rectangular piece, therefore, base into height, and the next one is supposed to be triangular system, half into base into height. Therefore, total area is to be taken, right? Then, if it is expansion, write down negative sign. If it is compression, it will be positive sign. This is your homework. Next. If suppose you are having this type of graphical representation, here we are having expansion, here we are having change in volume, decrease in volume, compression. right? Next, if suppose the graphical representation is given like this, that we are going from A to B, B to C, and C to D, total area under the graph. First take this one and then proceed to next. Right? Similarly, suppose for example you're having this type of graph, then what to do? Just draw a line here, in this case area under this half circle plus area under this total area, whole of the total area is to be considered. But suppose he's asking only from A to B, not here, CD is not given to you, then take only half of the circular path, the pi r square, yesterday what we have done, into r square. Go ahead, first take down these figures, right? Don't calculate that one. Just I am showing you how to go for the representation of the graphs. Total area is area under the graph, complete area under the graph. For this, you break up here. You break up here, A, B, C, and you write something and then join it. This is called area plus this area, this whole area, right? In this case, only this much, part one. If he's asking total area from this to this point also, then you have to calculate A plus B, otherwise only A. Take down these graphs, then I'll proceed. This is very much suitable for IIT students. Doctors, if you are understanding, go ahead. Otherwise, till yesterday's example, we can write it down as it is. Yesterday, I made some I said correction, by 2 here, by 4. Here also we have same thing, by 2, by 2. Shall I proceed? Wherever we are having clockwise process, you make it as negative, right? Okay. Now, till this time, these 9 topics, till this time, I have completed all nomenclature, right? And how to go for amount of work. Now, today, we are starting the complete base, beginning of the chapter, let us see. But all of these are possible as questions. Now, we have to go for first law of thermodynamics. Till this point, we have taken nomenclature, 0th law of thermodynamics, what is energy, what is heat, what is temperature, how do you calculate the amount of work done. Now our job is to understand first law of thermodynamics. Shall I proceed? Is it over? Draw the figures wherever we have clockwise, negative, anti-clockwise, positive. These 2 figures, left hand side, already we have taken yesterday, right? Take these 2 figures, right? This is one, this is homework. Check the value of the answer if pressure initial and final is given to you in this manner. Is it over? Have you written? Come on. First law of thermodynamics. This is the basic law, and this is actually our chapter. Our chapter is this one, but it needs all the things which we have discussed today. Otherwise, I cannot move. Okay. First law. What is first law? First law of thermodynamics is supposed to be simply law of conservation of energy. Right? Go back to your lower classes. That is known as law of conservation of energy. According to that law of conservation of energy, what we say, sir, we can neither create energy nor we can destroy the energy. However, we can have interconversion of different forms of energies. For that purpose, what we do, if I am choosing different forms, then the question is, what is which one, sir? Which form you are to select? In this chapter, we talk about heat energy. We talk about internal energy and we talk about work done. Work is a form of energy, heat is a form of energy, internal energy is also a form of energy. Therefore, how to have interconversion of these three forms of energies whenever you are having a chemical process or a physical process. Thermodynamics first law or any law of thermodynamics is applicable to both physical processes as well as chemical processes. So if you want to have interconversion, heat, work and energy, come on, how to proceed for that? For that purpose, according to this law, energy can neither be created nor destroyed, but it can be transformed into different forms. What are those forms? It deals with the relation between internal energy, capital E, heat energy, small q, don't write capital Q, and work of system. Work of system I am writing because it may be done by the system or on the system, right? This is given by small w. Q and W are written small, they are path functions. E is written as a capital, it is called state function. All capitals are given by state function, all path functions are given by small letters. Now, if you want to understand the concept of first law of thermodynamics, consider a cylindrical vessel available on the screen. In that cylindrical vessel, we are having certain amount of gas enclosed. Let us say the piston is available somewhere here. When this piston is available here, it means to say this is at thermodynamic equilibrium, right? That means outside pressure, inside pressure, both are same. Otherwise, piston would have been coming to downside or it is going to upside. No, sir, it is not moving. If it is static, then the question is, sir, we are having outside pressure and inside pressure, both are same. Now, job number one. What role number one is doing, he has taken a burner and he kept the burner downside. When you're having the system available, the gaseous system available, if the system is available at temperature T1, then we can say, sir, we are talking about energy E1. Okay, this is energy E1. Now, if suppose you are heating it, now Wajid, sound is okay? Is it clear to all of you? Audibility is clear? Right. There was admission process going on in our college. So it was something disturbing. No problem. Now, if suppose, for example, if I am having initial energy E1, what you have done? No burner, nothing. Simply you have taken a sample of gas. Now, roll number one came and he kept a burner below that one. What he is doing? He is supplying heat energy. What will happen? Nothing will happen, sir. Internal energy of the gas increases. What is the meaning of that? The gas molecules will have more amount of kinetic energy, thermal agitation. As the kinetic energy increases, the molecules will hit the piston with great amount of force. Not only they hit the piston, they hit all the walls of the container, but our interest is the piston because pressure is measured with respect to the force on the piston. Therefore, if role number one is supplying heat energy, number one, energy increases. Number one, energy increases. Number two, because of more energy, force acting on the piston increases. What happens? Slowly piston will move up. If piston is moving up, what is done? Expansion is done. Okay, work is done by the system. Work is done by the system. Suppose, for example, roll number 2 came here and he is, see the red color line on the arrow mark, that line is pushing downward. So roll number 2 is pushing the piston down. What happens? If you are pushing the system down, work is done on the system. Work is done on the system. Again, the gas molecules come close together. When they come close together, collisions increases. When collision increases, energy also increases again. Okay. Now see what happens. I am concluding the discussion. Role number 1, supplying heat energy, because of which internal energy increases. Okay. Role number 2 is pushing piston down. Again, energy increases. Suppose after doing both of these processes, final energy is E2. Initial energy was E1 before keeping the burner on, before keeping the application of the pressure. The energy was E1. Now I have kept the burner, I have pushed the piston down, work is done on the gas. If it is so, then energy further increases. What is that energy? E2. Now question is, total amount of increase in energy is because of what? You will say simply, sir, it is because of two things. One, roll number 1 supplying heat energy. Roll number 2, he is talking about amount of work done by 2. Therefore, work is energy, heat is energy. Both of this must be equal to increase of internal energy. I'll take numbers. Initially, energy was 100 joules. Roll number 1 kept burner, it becomes 200 joules. Roll number 2 pushed the piston downside, it becomes 400 joules. E1 100, E2 400. This total amount of energy is supposed to be, say for example, 500. Total. What happens? This 500 must be equal to heat plus work on the system. Heat plus work on the system. That is known as law of conservation of energy. Therefore, consider a cylindrical vessel in which certain amount of gas is enclosed. Certain amount of gas, यहाँ छूट गया देखिए, I'll write it later. Enclosed with a weightless and frictionless piston. ये हमको समझने के लिए practical नहीं हो सकता. Just we say, sir, इसका contribution कुछ नहीं होना चाहिए. I should not have contribution because of piston. If it is so, then say let us take frictionless piston. Easily it can move up and down. And weightless का मतलब है इसका pressure नहीं होना है. आप जो रोल नंबर 2 अप्लाई कर रहा है प्रेशर वही चाहिए. If it is so, let Q amount of heat energy supplied by roll number 1 to it and pressure is applied over it. Roll number 2 ये भी हो रहा है, ये भी हो रहा है. एरो मार्क देखिए, हीट का बर्नर देखिए. Increase in internal energy is equal to both the things. One heat and another one W. Now apply law of conservation of energy. Sir, Q plus W is equal to increase of internal energy. What is increase of internal energy symbol? Delta E. What is delta E? 400 minus 100. E2 minus E1. E final minus E initial. Therefore, first law of thermodynamics is given as delta E equals to Q plus W. Right? Hamesha, remember, whenever we say first law of thermodynamics, we should write change of internal energy is equal to Q plus W. After that, whenever problem is given to you, you have to apply sign convention. जो हम पिछली क्लास में कर रहे थे. If heat energy is absorbed, plus. Heat energy released, minus. And what is work? Always minus P external delta V. This is known as first law of thermodynamics. Q plus W is equal to delta E. Now, suppose for example, यहाँ पे आपको क्वेश्चन कुछ नहीं आएगा. हमको फर्स्ट लॉ अच्छी तरीके से समझ में आना है, राइट? क्वेश्चंस कहाँ पे आएंगे? उसके एप्लीकेशंस पे आएंगे. एप्लीकेशंस अब शुरू हो रहे हैं. फर्स्ट लॉ ऑफ थर्मोडायनामिक्स फॉर डिफरेंट प्रोसेसेस, राइट? सपोज फॉर एग्जांपल यू आर सेइंग सर आई वांट टू डू आइसोथर्मल प्रोसेस. क्या होगा? आइसोकोरिक प्रोसेस क्या होगा? लेट अस चेक इट वन बाय वन. Isothermal process. First of all, try to understand what do you mean by the word isothermal process. इसका मतलब है temperature is constant. नहीं sir, इसका मतलब है energy is also constant. No sir, इसका मतलब है E2 is equal to E1. No sir, इसका मतलब है delta E is equal to 0. Yes, these are the conclusions. एक वक्त अगर आपके सामने वर्ड आइसोथर्मल प्रोसेस आ गया, ये सब चीजें आपके दिमाग में आना है. आइसोथर्मल प्रोसेस मींस टेंपरेचर इज कांस्टेंट, सर एनर्जी इज कांस्टेंट, E2 इज इक्वल टू E1, डेल्टा इज इक्वल टू 0. अब डेल्टा इज इक्वल टू 0 लगाइए इन द एक्सप्रेशन ऑफ फर्स्ट लॉ. ओके, Q इज इक्वल टू माइनस W. क्या मतलब हुआ? It means magnitude of heat energy and magnitude of work will be same. If one is positive, another will be negative. Are you able to understand? यहाँ सिर्फ पूरा दिमाग की जरूरत है. Conceptually, you have to enjoy the beauty of each point, right? Line delta is equal to Q plus W पढ़ लिए, हो गया फर्स्ट लॉ? नहीं, एक एक लाइन पे आपको रुकना है, वहां समझना है कि what is the conclusion. वो conclusion ही 4 marks बनेगा. For this process, delta is equal to 0. Hence, Q is equal to minus W. मतलब क्या हुआ? Magnitude of Q और W दोनों सेम होंगे. 200, 200. No sir, this is 200 absorbed. अब जरा उसका मीनिंग समझो. System is absorbing 200 joules of heat energy. Therefore, system should do work. Sir, I have taken breakfast. I should work. I cannot sleep now. I have taken energy. Therefore, I should work. इसका मतलब है I should work. Work is done by the system. क्या आएगा? Negative आएगा. If heat energy is absorbed by the system, then work should be done. Work should be done by the system. Okay. Heat and work are equal in magnitude, but opposite in sign. ये conclusions निकाल रहा हूँ मैं, ये सीखिए. Conclusions कैसे निकालना है वो सीखिए. वो आपके questions बनेंगे multiple answer में. IIT के लिए, NEET के लिए normal question आएगा. चलिए, isochoric process. आपको first law कैसे आता है? This is first law. ABT is first law of thermodynamics for which process? Isothermal process. चलिए, isochoric process क्या मतलब हुआ? Isochoric process का मतलब है volume is constant. Volume constant का मतलब है piston move नहीं होगा. If piston is not moving, no displacement, no change in volume, no work done. अच्छा, अब आइए, डेल्टा E is equal to Q plus W. W की जगह जीरो लगाओ. क्या हो गया? Delta is equal to Q. Okay, magnitude of change of internal energy is equal to magnitude of Q. Both are positive, both are negative. Either be positive, either be positive. Throughout multiply by negative. अच्छा, minus delta is equal to minus Q. अब उसका meaning समझने की कोशिश करो. Plus Q is equal to plus E, plus delta E, plus Q. Energy is absorbed by the system. क्या होगा? Energy बढ़ेगी. Delta E positive. अच्छा, minus Q. Sir, energy released by the system. Minus delta E, energy is decreased from the system. Is it that? ये conclusions आना जरूरी है. W is equal to 0, isochoric process. Delta is equal to Q. Delta and heat energy are equal in magnitude and sign is also same. Remember that. Total amount of heat energy is used to increase internal energy. अब यहाँ पे जो interested point है, remember that total amount of heat energy is used to increase internal energy का मतलब है whenever heat energy is used by a system, the system can do two things. Job number one, it can increase internal energy. Job number two, it can do work also. अब यहाँ पे isochoric process में आप job number 2 को 0 कर दिए. Right? You are making as a scientist, sir, I don't want to move the piston. क्या करेंगे? Screw लगा दिए जो तरफ, piston will not move. That process is called isochoric process. The total amount of heat energy is used to increase internal energy only. Work नहीं होगा. तब डेल्टा E is equal to QV. इसको हम ऐसा लिखते हैं साइंस में. QV का मतलब हीट एनर्जी इन्वॉल्व. मैं यह वर्ड यूज कर रहा हूं, इन्वॉल्व मतलब एब्जॉर्ब भी हो सकता है, रिलीज भी हो सकता है. आई एम नॉट डिस्कसिंग साइन, आई एम डिस्कसिंग हीट एनर्जी इन्वॉल्व. ये जो सबस्क्रिप्ट में V लिखा हुआ है इसका मतलब है एट कांस्टेंट वॉल्यूम. Delta E is equal to QV. It is amount of heat energy at constant volume. इसको हम ऐसा लिखते हैं, ये फिजिक्स में पढ़ेंगे, लेकिन अभी आपको मैं बाद में समझाऊंगा ये रिलेशन कैसा आया. I'll explain that. एक अलग टॉपिक बनाएंगे. फिलहाल आप इतना ही पढ़ेंगे. Delta E is equal to QV is equal to NCV delta T. आपको ऑब्जेक्शन होगा, सर CV क्या है? CV is molar heat capacity at constant volume. I am insisting upon the word constant volume. Molar heat capacity क्या है? बाद में समझाऊंगा. ठीक है. डेल्टा E is equal to QV is equal to, ये इक्वेशन याद कीजिए, NCV डेल्टा डेल्टा T, you know it, T2 minus T1. चले नेक्स्ट. यहाँ रेड किया हूं, ये इंपॉर्टेंट है. What is QV? Till now what we are saying Q, right? Make a star. IIT people, make a star here in EBIT. Whenever we are discussing Q, remember that work done and Q, both of these are path functions. गौर से सुनिए IIT students. Q is path function. W is path function, but when you write Q with the subscript V, it becomes state function. क्यों? It is equal to delta E. Are you able to understand? सिर्फ Q लिखा हुआ है तो ये होगा path function. लेकिन Q के साथ अगर आप subscript लगा रहे हैं V, this becomes as a state function. 4 marks are available with you. चलिए, no sir, isobaric process. That is, I am maintaining constant pressure. मतलब piston move up and down. Volume variable. Isochoric process, constant volume का मतलब pressure is variable. Isobaric process, constant pressure का मतलब volume is variable. Piston can move up and down. यहाँ पे हम क्या बोले? Screw लगाइए. यहाँ नहीं सर, निकालिए. अब piston move होगा up and down, work होगा. Delta E is equal to Q plus W. Q plus, what is W? Mechanical work. What is the formula? Minus P external. यहाँ नहीं लिख रहा हूँ मैं external, हम इससे पहले कर चुके हैं. P external delta V. राइट. ये पूरे के पूरे टर्म्स अवेलेबल हैं. यहाँ हम डेल्टा पी नहीं है, वी कैन नॉट मेक 0. यहाँ क्या था? डेल्टा वी 0 था, यहाँ डेल्टा ई 0 था. हियर इन दिस केस एवरीथिंग इज अवेलेबल, मतलब जरा गौर से सुनो क्या बोल रहा हूं मैं। टोटल अमाउंट ऑफ हीट एनर्जी इज यूज्ड टू इंक्रीज इंटरनल एनर्जी ओनली इफ इट इज आइसोकोरिक प्रोसेस। दो काम करना था, आप सिर्फ एक काम कर सकते हैं, वो है इंक्रीज ऑफ इंटरनल एनर्जी। अगर प्रेशर कांस्टेंट है, इफ प्रेशर इज मेंटेन कांस्टेंट, दो काम भी कर सकते हैं, एक एनर्जी इंक्रीज होगी, दो पिस्टन मूव होगा ऊपर, वर्क भी होगा, यू कैन डू वर्क आल्सो। देयरफॉर इन आइसोबारिक प्रोसेसेस हीट जो सप्लाई करेंगे वो ज्यादा होगी। इन आइसोकोरिक प्रोसेस इसको हीट कम चाहिए क्योंकि ये एक ही काम करने वाला है, इसको हीट ज्यादा चाहिए, इसके पास दो काम होंगे। क्यूपी क्या क्या काम होगा, एक तो एनर्जी बढ़ेगी और एक वर्क होगा, प्लस पी डेल्टा वी। अब यहां मैं पी डेल्टा वी लिख रहा हूं, आई एम नॉट डिस्कसिंग एक्सपेंशन कंप्रेशन, वर्क, पीवी वर्क जिसको बोलते हैं ना, वो ऐसा है। इसका मतलब अमाउंट ऑफ हीट एनर्जी absorbed by the system is doing two jobs now. One is increase of internal energy, another is work. Next, what is delta E? E2 minus E1, right? Doctors, IIT students, now I am going to derive one thing here. Delta E final minus initial, P is P external, ये तो constant है isobaric. V delta V, V2 minus V1, सर पिस्टन ऊपर उठेगा, V2 minus V1, सर पिस्टन नीचे जाएगा, compression. If you are saying like this, अब जरा और से देखो क्या करें, E2 यहां से क्या कर रहा हूं मैं, PV2 इधर ला लिया, ये दोनों को पेयर बनाया, माइनस E1 PV1 को एक पेयर बना लिया। अब E प्लस PV ये जो प्रॉपर्टी है, लिसन केयरफुली, इन थर्मोडायनामिक्स तीन जगह पे, आपके सिलेबस में दो जगह पे, डिग्री वालों को तीन जगह पे हम लोग डिफाइंड इक्वेशन कहते हैं। वी डिफाइन सम इक्वेशन, डिराइव नहीं, डिफाइंड। कैसे करेंगे उसको, ये फॉर्मूला है, याद रख लो, H इज इक्वल टू E प्लस PV, इसको कहते हैं डिफाइंड इक्वेशन। ये जो E प्लस PV है ना, this E plus PV is called H. What is H? Enthalpy. Yes, this is known as HE2 plus PV2, H2. E1 plus PV1, H1. What is E? Internal energy. What is it? Enthalpy. अच्छा सर, दोनों में फर्क क्या है? E is internal energy. What is enthalpy? Internal energy plus work. एनर्जी प्लस वर्क अगर मिलाएंगे तो उसको कहेंगे एंथैल्पी। E प्लस पीवी को H बोलेंगे, सिंपली E को इंटरनल एनर्जी बोलेंगे। अब यहाँ पे हम क्या करें, QV, व्हाट इज दिस QV? अमाउंट ऑफ हीट एनर्जी इन्वॉल्व्ड एट कांस्टेंट वॉल्यूम इज इक्वल टू चेंज ऑफ इंटरनल एनर्जी। नो सर, आई एम सेइंग डिस्कशन ऑफ अमाउंट ऑफ हीट एनर्जी इन्वॉल्व्ड एट कांस्टेंट प्रेशर। ये क्या बनेगा, H2 minus H1 डेल्टा H। ये बहुत बड़ा माइलस्टोन है थर्मोडायनेमिक्स चैप्टर में। QV डेल्टा E, QP डेल्टा H, मतलब अमाउंट ऑफ हीट एनर्जी इन्वॉल्व्ड एट कांस्टेंट वॉल्यूम होगा डेल्टा E। यहाँ वर्क नहीं होगा बिकॉज वॉल्यूम इज कांस्टेंट। इन आइसोबारिक प्रोसेस QP वर्क भी होगा, एनर्जी भी बढ़ेगी, दोनों को मिला के हम एक नया फंक्शन डिफाइन करेंगे, उसका नाम है एंथैल्पी। दैट इज QP is equal to H2 minus H1 delta H। जैसे यहाँ NCV delta T लिखे, यहाँ पे क्या लिखेंगे, NCP delta T। What is CV? Molar heat capacity at constant volume. What is CP? Molar heat capacity at constant pressure। ठीक है, अब सर E हमको सब कुछ मालूम है E के बारे में, E is extensive property, is state function। What about delta H? Delta H is also extensive property and this is supposed to be a state function and it is always given as QP। P साथ में नहीं लिखना, P सबस्क्रिप्ट लिखना हमेशा, यहाँ गलत है, देखो Q के साथ में P जो आता वो सबस्क्रिप्ट लिखना, जैसे यहाँ लिखा हुआ है ना, ये देखिए QP, यहाँ पे भी QP नीचे आना है। डेल्टा H is a change in enthalpy। What is delta E? Change in internal energy बोले थे ये। What is this? It is a state function और ये एक एनर्जी है, फॉर्म ऑफ एनर्जी है, ये एक्सटेंसिव प्रॉपर्टी है। H is extensive property, H is a state function। Please write down this, then we'll proceed। Go ahead। डायरेक्शन ऑफ एरो सही ड्रॉ कीजिए। क्यू को अगर डायरेक्शन देना है तो अपवर्ड एरो दीजिए क्यू के पास। अगेन प्लीज डोंट आस्क अगेन, नो डोंट आस्क अगेन, डाउट है तो पूछिए, राइट। मैं इससे पहले भी बोला हूं बेटा, आप क्लास में हमारे साथ हैं, इत्तेफाक से आप मेरे साथ अटैच हुए हैं फिजिकल केमिस्ट्री के लिए, तो मुझको पहले समझिए। मैं कम से कम 10 वक्त बोल चुका हूं, डोंट आस्क प्लीज अगेन एक्सप्लेन, बजाय उसके आपको पॉइंट पूछो, क्या पूछना है। ई पॉइंट जो आप बोल रहे हैं वहां पे ई के अंदर लिखा हुआ है क्यूवी। चलो, व्हाट इज क्यूवी? क्यूवी इज इक्वल टू डेल्टा ई। अब बोलो ई क्या है? ई इज ए स्टेट फंक्शन, इसलिए मैं इसको स्टेट फंक्शन बोल रहा हूं। क्यूवी इज इक्वल टू डेल्टा ई। अगर यहां से वी हटा दो तो कैन यू राइट इट डेल्टा ई? नो। देयरफॉर व्हेन यू आर सेइंग क्यूवी डेल्टा ई, यस सर, द प्रॉपर्टी व्हाट यू आर सेइंग डेल्टा ई स्टेट फंक्शन, क्यू आल्सो स्टेट फंक्शन। इज इट क्लियर? सिर्फ क्यू को स्टेट फंक्शन नहीं बोलेंगे, क्यू को आप सब्स्क्रिप्ट लगाइए वी, दैट मींस हीट measured at constant volume, state function. I see, if you are interested you can say like this, sir what about qp? Qp is also state function. Listen all of you, qp is also state function. Why? Sir qp is equal to delta h, एक state function है, ठीक है। Is it clear now? That is the method of asking the question. Nice. I hope you understand my method of teaching. वही पॉइंट को पूछिए, मैं एक्सप्लेन फिर पूरा समझाओ, आपका टाइम वेस्ट, मेरा टाइम वेस्ट। यस, यू आर राइट इब्राहिम, यू आर राइट। बी लाइन, व्हाट इज दैट? बी मोहम्मद, हु इज दिस बॉय? मोहम्मद रबा। आइसोबारिक में क्या प्रॉब्लम है बेटा? वहां पे QP का मतलब है अमाउंट ऑफ हीट एनर्जी एट कांस्टेंट प्रेशर इज इक्वल टू डेल्टा ई। यहां देखो Q इज इक्वल टू ये डेल्टा ई, माइनस भी डेल्टा वी को उठा के इधर लेके आओ तो प्लस होगा ना बेटा। रीअरेंज किया हूं मैं, पॉइंट बी में सिर्फ रीअरेंज किया। उसके बाद डेल्टा क्या मतलब है आपको मालूम है, फाइनल माइनस इनिशियल, उसको एक्सपैंड किया। डेल्टा वी क्या मतलब है, उसको एक्सपैंड किया। फिर 2 वालों को एक तरफ कर लिया, 1 वालों को एक तरफ कर लिया, और से एक नई चीज मिली E2 PV2, उसको एक नया नाम दिया H2। अच्छा, E प्लस PV को क्या कहते हैं? H कहते हैं। व्हाट इज E? एनर्जी। व्हाट इज PV? वर्क। अच्छा, एनर्जी प्लस वर्क इज कॉल्ड एंथैल्पी। चलिए, गो अहेड। Is it clear? Yes. B point only I have explained just now. Very good. Go ahead. Go ahead. Is it over? ठीक है, write down. Go ahead. షెడ్యూల్స్ అన్ని అయిపోయాయి. కొంచెం అన్ని షెడ్యూల్స్ సీడాడల్లో పెట్టి సీనియర్ అన్ని ఒకటి కావాలా, జూనియర్ అన్ని షెడ్యూల్స్ అన్ని సెపరేట్ పెట్టి ఒక నోట్ ఇచ్చేయండి. ఇది సీనియర్ స్టార్. సీనియర్ స్టార్ లో అడ్వాన్స్ బ్యాచ్ లో అంత చేంజ్ చేసుకున్నారా?
చేసాను. అంటే అది 20 కదండి, మన 18 అంటాం కదా.
20లో డేట్స్ వేసేసారా?
20
ఇది ఒకటి అయిపోయింది. దాని తర్వాత సీనియర్ ఎక్సెల్ 1 ఎక్కడ ఉంది? 10 వీక్ ప్రోగ్రామ్ కదా. నీట్ 1 నైస్. దెన్ నీట్ ఎక్సెల్ 2. The senior Excel 2 need to ఉన్నదా? need to తర్వాత సీనియర్ అయిపోయింది. ఇది సీనియర్ ఐపీ బ్యాచ్. ఇది బైపీసీ వాళ్ళకి, ఇది ఎంపీసీ వాళ్ళకి. జూనియర్ సీనియర్ కంప్యూటర్ వచ్చేసింది. జూనియర్ లో జూనియర్ స్టార్ ఒకటి, జూనియర్ ఎక్సెల్ ఒకటి, జూనియర్ ఎక్సెల్ 2 ఉండాలి కదా. జూనియర్ నీట్ 1 వెరీ గుడ్. జూనియర్ నీట్ 2, జూనియర్ ఎక్సెల్ 2. ఎక్సెల్ 1 ఎవరు? ఇక్కడ ఉంది. ఎక్సెల్ 1, ఎక్సెల్ 2, దెన్ నీట్ 1 ప్రోగ్రామ్, నీట్ 2 ప్రోగ్రామ్, తర్వాత మనకు ఎంపీసీ అండ్ బైపీసీ. ఇప్పుడు మనకు బ్యాక్లాగ్ ఏం లేదు, అన్ని బ్యాచెస్
వచ్చేసేయండి. జూనియర్ స్టార్ ఏం లేదు.
మనం ఏం చేసుకోవాలంటే రేపు మనకు అదే మార్నింగ్ టు ఈవినింగ్ వర్క్ షాప్ లో ఎవరెవరు లెక్చరర్స్ సిలబస్ ఇవ్వలేదు అదంతా రాసుకుని రేపు ఫైనల్ చేసుకున్నాం. ఇప్పుడు మనకు ఏం కావాలంటే టెస్ట్ ప్రోగ్రామ్ కోసం కావాలా. నేను క్లాస్ అయిన తర్వాత సరే ఏ టెస్ట్ ఇప్పుడు ఉన్నాయి, ఆ టెస్ట్ పేపర్ ఎక్కడ నుంచి తీసుకున్నాను చేయండి.
మనకి రాలేని పొద్దున పట్టుకుని చేస్తాను. నెక్స్ట్ సార్ మీరు ఇస్తారని పెట్టేయండి.
ఏంటిది? థర్మోడైనమిక్స్ అండ్ థర్మోకెమిస్ట్రీ. మంచిది. మీ దగ్గర ఏమున్నాయి ఇస్తే మీరు పెట్టండి, చూపించండి. దాంట్లో టిక్ చేసేమంటారు. నేను చూడలేదు, నేను క్లాస్ తర్వాత చూసి చెప్తాను. రైట్. Is it over? H इज इक्वल टू E प्लस PV। कहीं पे एक जगह लिख के उसको बॉक्स बनाइए, यहीं पे B पॉइंट में, यहाँ B जो पॉइंट है ना वहां पे बाजू में H इज इक्वल टू E प्लस PV। यहाँ पे E2 प्लस PV2 H2, E1 प्लस PV1 H1। दिस इज डिफाइंड। ये कैसा आया सर? हम दोनों एनर्जीज को मिला के एक नया नाम दे रहे, दैट्स ऑल। नाम है एंथैल्पी। ये एक एनर्जी है, इंटरनल एनर्जी। ये एक एनर्जी है, वर्क इज अ फॉर्म ऑफ एनर्जी। फिजिक्स पीपल से डायमेंशन फॉर्मूला ml2 T-2, work and energy both are dimensionally same. So E plus PV H2, E2 plus PV2 H2, E1 plus PV1 H1, delta H. This delta H is called change in enthalpy, ENTHALPY. Go ahead. डॉक्टर्स, कभी बाहर निकले आप शॉपिंग के लिए तो एक छोटी सी बुक लीजिए, नोटबुक 100 पेजेस की, पहले जो आप यूज करते थे स्कूल के टाइम में छोटे छोटे असाइनमेंट्स के लिए बुक, वैसे लिख के डेली क्लास होने के बाद इवनिंग बैठ के उसमें से कितने फॉर्मूलाज, ऑल द फॉर्मूलाज यू हैव टू कलेक्ट एट वन प्रॉपर प्लेस। फॉर्मूलाज कलेक्ट करना, टिपिकल पॉइंट्स कलेक्ट करना। आज का टिपिकल पॉइंट क्या है? Q is a path function, Q is state function. Q is a path function, QP is a state function. Simple points, and all those points are individually possible questions. एक बैंक, बिट बैंक जैसा बोलते हैं, वैसा आपके पास एक पॉइंट बैंक बनेगा। हर चैप्टर का एक पॉइंट बैंक बनेगा। वो पॉइंट बैंक कभी आप खाना खाते बैठे हुए हैं, बाजू रख के आहिस्ता से देखते रहना क्या है उसके अंदर। Is it over? I'm having offline class now. Completed, right? That will stop here. Tomorrow we'll discuss what is remaining part. कल तक जो complete होगा, that whole will be available in Sunday examination, right? If possible, if necessary, I may take class on Saturday also, right? If suppose students are sincerely available, then the class will continue. Again, you have to suffer for one more week. So please try to manage that. Thank you. Assalamu alaikum. Thank you, Beta.